Hi guys, here's a quick video to get you started in solving systems with elimination. So to get you going, I have got my couple examples to show you how to do this in your homework for tonight. Alright, so first thing I'd want you to get down here is a couple rules for elimination. The first rule of elimination is that you need to stack your variables. And what that means is your variables need to be lined up. So your x's need to be over your x's and your y's need to be over your y's. Basically that means your variables need to be, or I should say your equations need to be in the same form. So all in standard form or all in slope-intercept form, they need to look the same. Okay, then in order to do elimination, you need to have opposites. So what I mean by opposites are, you need to have one that's a positive variable and one that's a negative. And so if you have opposites, then we get to go and follow this method here and add our equations together. Just thinking when you have opposites, remember you've got, if you add them, -2 plus 2 gives you 0, which is where the elimination comes from. If you don't have opposites, then you need to make opposites. And I'll show you how to do that here in just a second. All right, so first example, we're going to use elimination to solve this system. -3x minus 4y equals -1, and 3x minus y equals -4. What's really nice about this system is that we have opposites right away. You can see them in those x's, -3x and 3x. So since we've got opposites and since our variables are stacked, I should say that first, they're both in the same form, we can go ahead and add our equations. And I like to set this up so that it's kind of like an old school addition problem. You just work it from the top down to the bottom. So -3x plus 3x is eliminated. So I'm just going to cross that off. -4y minus another y, or another 1y, is -5y. -1 plus a -4 is -5. Then to get y by itself, I'm going to divide by -5. Negative divided by negative becomes a +1. All right, so I've got my y. So over here for my system, I'm going to make my xy coordinate point and plug in 1 for y. Then you just need to figure out a way to get your x. So you need to go back to your original two equations, pick whichever one looks like more fun. I'm just going to pick the second equation, and I'm going to substitute 1 in for y. So I've got 3x minus 1 equals -4. So this just takes a little bit of algebra. I'm going to add 1 to the other side. I am going to divide by 3. And this gives me a solution of x is equal to -1. Ooh, that was fun. So you plug that in to your ordered pair. This means we have one solution to this system. That solution would cross at -1, 1 on the coordinate plane if we were to graph those. Awesome. All right. Next example, once again, want to use elimination to solve this. We've got 2x plus y equals 23, and 3x plus 2y equals -37. All right, so the first thing I notice, okay, my variables are stacked. X's are over x's, y's are over y's. My constants are over themselves as well. But I don't have opposites. There aren't opposites in my x's or in my y's. But I do notice that since this is a single 1y, and the y below it is a +2, it'd be really easy to turn that into a -2 by multiplying the entire equation by -2. So this is what I mean by using the distributive property. We're going to distribute -2 to every single term there. And when I slide this over, I end up with -4x minus 2y equals -46. Now the biggest thing you got to remember is to distribute to every single term. If you don't distribute to every term, that's where you could run into goofs. My second equation I'm just going to slide over. 3x plus 2y equals 37, because I see now I've got opposites. And now I'm going to add my equations and see what's left over. So -4x plus 3x is -1x. -2y plus 2y is eliminated. -46 plus a +37 is -9. Then to get x by itself, I'll divide by -1. So x is equal to 9. So I'll make my ordered pair off to the side, substitute or plug in 9 in for x, and then I just need to pick either equation again just to solve for my y. You know, honestly, it doesn't matter. I'm probably going to pull this top equation again and then substitute 9 in for x. So it's going to be 2 times 9 plus y equals 23. 2 times 9 is 18. When I take 18 away from 23, I'm left with 5. So there you have it. We've got one solution at 9, 5. And this is an example showing you how you can alter one equation using the distributive property by just picking any number that you need in order to make opposites. Last example, before we let you go here, is this final system of equations. We've got 4x plus 2y equals 8, and 3x plus 3y equals 9. What's different about this one is noticing that those x's and those y's, yes, they're all lined up and they're good to go, but there's no nice way to make opposites just by altering one equation. So you have to alter both. You're going to have to use the distributive property in both cases here. And it doesn't matter if you want to multiply the top and the bottom equation to make opposites in your x's, great. I'm just noticing that my y's, I could get a smaller factor there, or multiple with 2 and 3 by making my 2y, if I multiply by 3, I'm going to get a 6y, and then if I multiply by negative 2 in my second equation, I'm going to get negative 6y. Just remember to distribute to everything. And so if I slide this over now, I've got 12x plus 6y equals 24. Sliding over my second equation, I've got negative 6x minus 6y equals negative 18. Now that I have opposites in my y's, I'm going to add my two equations together. 12x minus 6x is 6x. 6y minus 6y is eliminated. 24 minus 18 ends up being 6. And then divide by 6. So x equals 1. To find my y, once again, I can pick any equation. You really could go with any of your originals, or if you want to choose an altered one. I'm just going to go with my original equation. I might pull the bottom equation this time just for fun, and then substitute x in so I can solve for y. So I've got 3 times 1 plus 3y equals 9. 3 times 1 is 3. When I take 3 away from 9 on both sides of the equation, I've got 3y equals 6. Divide by 3, and that leaves me with y equals 2. So one solution, these two equations would cross at 1, 2. All right? So those are 3 examples to help you with your elimination assignment tonight. I hope that helps. And if you have any questions, bring them to class the next day, and we will help you out. Good luck.